Okay, welcome Kyle and welcome Dominique. This is the week 8 webinar. It's the exam week, so I'm going to make it shorter than normal webinars. And what we're going to talk about today is chapter 10. And the good news is that chapter 10 is a couple little new things in chapter 10, but really it's just an adjustment from what we did in chapter 9. So I'll give you some examples, but there's really very little theory or new ideas to tell you about, other than we're going to have 2 samples instead of 1 sample. That's really the big difference. And we're going to use a different button on the calculator, but all the ideas are the same. We're going to be talking about a null and alternative hypothesis. We'll talk about a level of significance. We'll talk about a p-value and whether to reject or fail to reject the null hypothesis. And that's pretty much it. There's going to be 3 kinds of tests to look at today. One is a test for 2 proportions. Another is a test for the difference of 2 independent means. The third will be the test for the difference for paired differences, what we call it, also called dependent differences. So there's 3 types. And the hardest part that we're moving into now is to figure out what to do. So we're going to start having lots of different kinds of hypothesis tests. When you're in chapter 9, we only had proportions and means. Now we're going to have 3 more, and the next week we'll have some more, and the week after we'll have more, the week after we'll have more, and pretty soon you're going to have this big, long list. And the first step is sometimes the hardest step is to decide where on the list you're going. So I'll try to talk about that a bit. Are there any questions? And also I'm going to talk about the project. Are there any questions before I get going? Kyle or Dominique?
You just sent me an email about the midterm. And I actually emailed the school to try to set up a proctor, and the email address doesn't work.
Are you in Tahoe?
Yes, I am in Tahoe.
Okay. What you might want to do is pop in tomorrow in the library and see if they can take you.
All right, I will do that tomorrow.
Yeah, you need to take it tomorrow, and don't wait till evening because they close.
Okay, I mean, I've worked tomorrow, but I might be able to get off.
All right, do what you can. It's not like, the first day class, we talked about this, so it's not like it's a big surprise that tomorrow's the deadline. So I can't do much other than let you know it's a 10% per day penalty for being late. And that's really cool. So it's much, much, much better to take it tomorrow. Because you can get an A if you don't take it tomorrow. Let's put it that way. So try and pop in and call if you can. If you just call the college, which is 530-541-4660, and ask for the library, then they'll get you through to the library, and you can talk to them too. You can do it by phone.
Yeah, I sent them a message, but it was at 7 o'clock and they didn't answer. So
yeah, because they were
just left a message.
Just closed. Yeah, they close at 7. So, which sometimes means they stop answering at 6:58 or something. You know how that works.
Right.
Okay. They open tomorrow at 9. That I know for sure.
Okay.
Okay. Any other questions? Okay. So what I want to do is I want to share my desktop and show you. I like to bring in a current event if we can. And Gallup is my favorite because it gives you the sample sizes so we can actually do the analysis. If you look at regular articles, they often don't show you the data. The data was done, but it's not written in like a news article. So I'm going to pop in a little Gallup. Share screen. Okay, so you should be able to see this. And the news article, the topic is presidential moral leadership, less important to Republicans. Okay. And of course, it's a little confusing what that really means. And I want to look at something a little bit different than what the title says, because they've already done the hypothesis. I want a new hypothesis. I want to say, well, when they say less important, they're looking at, I'll show you, Clinton versus Trump. So they did a survey when Clinton was the president, and they did a survey when Trump was the president. And we want to find out, and let's forget Republicans, just look at people, okay? U.S. adults. You always want to do adults. You never want to survey children. So let's look at people and find out if U.S. adults, has that gone down? Has that gone down? And again, the survey question was, how important do you think it is for the president to provide moral leadership for the country? Very important, somewhat important, only slightly important, or not at all important. And they looked at the percentage of people who thought it was important. And we want to find out whether it has gone down for the Trump administration versus the Clinton administration. Okay, and this, like pretty much everything about America, is that you never know the data for every person in all of America. They didn't know then and when Clinton was president. They don't know now when Trump is president. So this class, hopefully you've got the idea. When you can't get everyone, what do?
Sample size.
Yeah, you take a sample. Okay, you take a sample, and when we go to the very bottom, that's why I usually use this particular site, is that because I can go to the bottom. And they say is that they used 1,024 adults. Okay, they didn't say when they used before, so I'm going to call it 1,000. Let's suppose they used 1,000 for the Clinton time because it didn't show in this article, and 1,024 for the for now, this most recent survey in May. Okay, so what we want to do is we want to find out whether there has been a drop in those who think morality is, for a president is important. Any questions on that? That's going to be a fun little article because it's big in the news lately, right? Everyone's talking about it. And I know some of you weren't even, like, hardly even born at Clinton's time. Maybe you weren't born. But in those days, there was the same issue. I don't know if you know your history, but you know what the issue was then? Similar issue, actually. You know Clinton's issue?
Morality.
Yeah, but specifically? He had a very specific issue. He screwed around with the secretary. That was the morality. Okay, and he screwed around with the secretary, Monica Lewinsky, and there were moral issues. Okay, and Trump has similar issues, right? So what we want to do is want to find out if there's a difference. We want to think, how is this different from what we did last week? What's the difference between this week and last week in terms of a hypothesis test for this? Anyone, either of you?
It's because it's like two different samples?
Yeah, here we have two different samples instead of a sample compared to a population. So when you have two different samples, you don't know either of them. You're not finding out if some mean is greater than a number. You're trying to find out, or a proportion is greater than a number. You're trying to find out if this proportion is greater than this proportion, okay, or less than or not equal to. So all the rest is the same, but that's the new piece, is now we have two different populations. We're taking a sample from each population, and we're comparing them. And when you do that, we're going to have a hypothesis test for the difference between two proportions. So I'm going to write a couple things down. I'll let you know. So we had 1,024, and I'm telling you Clinton's time was 1,000, which is somewhat of a guess, but it's probably pretty close. And if you look at the percents, it was 72% for Clinton's time, and it was 66% for now. Okay, so those are the numbers we're going to need. Any questions so far? Okay, and this is a news article. And when you have a news article, what is the level of significance you usually go by?
95? Or, 0.05?
Yeah, 5%. So 0.05 is the level of significance you always use in any kind of political science or psychology or that. You always use 0.05. That's standard. Okay. Sometimes in medicine you'll use something different because you're going to hurt somebody. But no one gets hurt on this. It's just kind of a fun little article. Does that make sense? Okay. So the next thing we do is you might guess is I want to write down the null and alternative hypotheses. And that is that guy. All right, so what we can do, let me go to text. No, black's fine. And don't want 48. 18 looks better. Is we're going to write down H naught. And here again, this is a yes or no question, right? The question really in terms of what they're looking at is, do you think morality for a president is important? And it's a yes, no, it's not quantitative. So that means we're dealing with proportions. And when you're dealing with proportions, use the letter P. Hopefully you're used to that because that happened in chapter 9 and also in chapter 8. So we're going to use the letter P. And there's lots of ways of writing it. You can call it P1 and P2. That's what the calculator is going to want. You can also say call it P, C, and PT for proportion during the Clinton era and the proportion during the Trump era. I like that better, actually. So PT for proportion during Trump time is equal to PC for proportion during Clinton era. Any questions on that? Is it starting to look similar to last week? Okay, then you're going to have H1, and that's going to be PT. And what we want to find out, has that morality idea gone down in importance? Does that make sense? So what inequality do I want? Greater than, less than, or not equal to?
Less than?
Yes, less than. And notice if I'd switched them and done PC equals PT, I'd have a greater than. So you have to be consistent. You can choose whatever you want, but you got to be consistent. PT is less than PC. Any questions on that?
Did that state it in the article that they were curious if it went down?
Yeah, the article said Republicans are less interested in morality than they used to be. So now I'm saying, well, what do you think it is for everyone? Is that true of everyone or just Republicans? Does that make sense? Mm-hmm. Okay. So in a question on a midterm, I'll let you know, right? The word less than or greater than will be there or something like that. Increase, decrease, something like that. Okay, so now we need to go to our calculator. This will be a new button, but nothing real new. That's the good news. So here's the calculator. And then I'm going to go ahead, and you're used to this button, stat. It's the button in this class. I hit the right arrow twice. And what I want now is we have two samples, and their proportions. It's yes or no. So what we're going to use, any guess?
Two
sample z-test?
Okay, it's two prop z-test because it's proportions. To sample would be for means. Okay, and that's really the calculator's way of saying it. It's not necessarily formal statistics, but the calculator does it that way. And since you use this calculator, you need to know how to use a calculator. Okay, so I'm going to go down to two prop z-test. And by the way, you need NP and NQ greater than 5 for both populations. Okay, in this case, they're much greater than 5 because we had over 1,000 people surveyed, and we're looking at proportions of 66% and 72%. So 66% of 1,000 is 660. And if you take 1 minus that is 34% of 1,000 is 340. Well bigger than 5. If you're not bigger than 5, you just can't do this. Does that make sense? Mm-hmm. It's not the sample size, but it's the NP and NQ. Yeses and nos. Okay, so I'm going to go ahead and hit enter. All right, and we want X1. And X1, that was 66% of 1,024. And you can use a calculator on that, but you need to put a whole number here. So if it gives you a fraction or decimal, you have to round. And I got 736. Any questions on that? Maybe I should double check, but I think that was the one I got. Oh, I got 676 is what I got. Let me double check. So 0.66 times 1,024. And yeah, 676, sorry about that.
Wait, it's what's the percentage for Trump?
Trump was 66%.
Oh, okay.
And 66% of 1,024 is 676.
I wrote it down wrong.
Yeah, and that just came from the article.
Okay.
That's not math or anything. That's just what they did. Okay, and I chose 1,000 because then I could do that easy in my head. But it's probably around 1,000 for Clinton, and that was 72% of 1,000. That's 720. I could do that without any serious amount of effort. Out of 1,000. Any questions so far?
How did you determine? Oh, okay. So you put the first one in the hypotheses. You put X1 and N1 are the first on the left side of the sign, right?
Yeah. The ones are the left and the twos are the rights.
Okay.
Exactly. Good question, though. Okay. And then we have a lesson. That was in a hypothesis, right? So I hit enter on that. I have no idea why they ask us for color. Just ignore it. The older calculators don't have color, I think. And I hit enter. Any questions before I hit enter? Okay, and it gives us what you expect. It gives you a p-value. That's the big thing, right? The test statistic, by the way, is z equals negative 2.9 about, but the p-value is 0.0018. Let me write that down. Is that clear so far? Okay, so now I go ahead and I go to here, and let me remind you the p-value was 0.0018. Any questions on that? Okay, now, if you understood anything about Chapter 9, then you should know what to do if the p-value is 0.0018. What do we do?
You interpret it?
Yeah, but in particular, when you have this p-value.
Oh, you reject.
We reject, because p is very small, less than 0.05, very much less than 0.05. And now we reject, and now let's write that in words. So we can say there is, I'm going to write strong because 0.0018 is very small. It's not like 0.04, it's really tiny. Statistically significant evidence to conclude that the proportion of all Americans, or US adults is what they called it, who now think that the president having morality is important, or a moral president is important, is smaller. And actually the population proportion, because you want to emphasize that we're talking about everybody, is smaller than the population proportion from the Clinton era. Any questions on that? Do you agree that this is very similar to last week?
Yes.
Okay, yeah, it's really similar. but there's a different calculator button. We're dealing with 2 samples instead of 1 sample. So last week was kind of an easy start, and now we're getting into more details. And it turns out the 2 sample is used much, much more often than 1 sample. Comparison studies are what most people do. But 1 sample is important, but 2 samples come up more often.
So the way you interpret the p-value is the same, though.
Yeah, so I'm not going to write it all out because it's long, but you would say that if the population proportion who think that presidents should be moral was the same in the Clinton era as it is now, and if you did another study of 1,024 people now, and I guess you couldn't do it, or had you done another study, because you can't do it now that it's over, and 1,000 people in the Clinton era, then there would be a 0.18% chance that it would have declined by at least 6%.
Okay.
And the 6% is 72% minus 6%. That's minus 66%. Does that make sense? It's exactly the same. It really is exactly the same. Does that make sense? All right, let me give you another example. And now I'm going to give you more of a stock example than a example of an article. So let me get rid of this. And let's do a new one. Okay, so in this one, a manager wanted to see if people spend more money in her gift shop if they are given a free piece of candy when they enter the store. Sounds like an important thing in business, right? Okay, if it works, then you're getting better customers and getting more money. If it doesn't work, you're wasting money on candy. Right? There's no such thing as a free piece of candy. You get it, but then you spend more. Okay, I don't know if you've ever been to a store where they gave you free food. Sometimes market, sometimes little gift shops, whatever. And that's the reason. Okay, so below are the receipts from the 12 customers who are given candy and the 12 who are not given candy. So the first thing to notice on this is that this first person who has a 25 for candy and the first person who was not given candy, who spent $37, they have nothing to do with each other. It's not like a couple and you're giving one candy and the other not candy. Does that make sense? It's just the first row of this table is from the group of people giving candy, and the second row is from the group of people who are not giving candy. Does that make sense? So that's important. That makes them independent. Okay, so now what we want to do is find the test statistic and the p-value. We need to get a hypothesis. So what's the difference in this example and the one I just did?
The previous one was proportion, and this is going to be mean.
Exactly. The previous one was proportion. This one's going to be mean, so we're not going to use the letter P on this one. We're going to use what letter?
Mu.
Mu. Okay, which is why I got to do it with a pen, because you can't do mu on a keyboard. So mu. And what we can do is maybe mu C for mu candy. The mean for those who got candy is equal to mu N for no candy. Any questions on that? And then H1. Okay, we're still going to have a mu candy. Mu C. Okay, and now what inequality?
Mu C is greater than.
Yeah, greater than, because the keyword more. Do you see that? And I don't give trick questions, but you do have to look for words like more. And hopefully you all know more is the greater than sign. Any questions so far? Okay, so now we do what we're used to doing. We go to the calculator. Hopefully you're good with that at this point. So let me go to the calculator. So that's what we had. Now I'm going to go to stat. I have data put in, so I need to edit. I'm going to go up to L1. I'm going to hit clear and enter. I'm going to go over to L2. I'm going to hit clear and enter. Notice we have an L1 and an L2 now because there's the candy column and the none column. Then I'm just going to type my data in. So 25. Shoot. Sometimes if I don't type hard enough on the keyboard, it doesn't work. 14, 160. By the way, what do you call that 160 person?
Outlier.
That's an outlier. 98, 55, 18, okay, 29, 44, 91, 83, 17 and 32, and then L2, we're going to have 37, going to have 51, 40, 37, 40, 22, 21, 9, that's right, missed it, 9, 30, and then 28, 19, and 11. By the way, can a study be done where there were, say, more people who were given candy than not given candy? Would that be all right for this study like this? What do you think?
I think maybe yes, because it's average.
Yeah, it's fine because you're allowed to have different sample sizes when you're doing independent samples.
Oh, okay.
That won't be true for dependent, as we'll see in a bit. But for independent samples, it's fine to have more of one than another. Okay, so then I'm going to go ahead and hit stat. I'm going to go to tests. And which one do you think it is this time?
To sample z-test?
To sample t-test.
T-test.
Yeah, Z, we're never going to use Z in this class. To sample z-test. That's only when you know population standard deviations, which never happens.
Okay.
So to sample t-test.
And on last, oh, sorry, can I ask a question real quick?
Sure.
On last week's test, we did use z-test because when it gave us like this, when it just said that in the problem, right?
Right, and that only happened in the regular, like, worked out assignments, not on your exam.
Yeah.
Which I promised you before, so I'm not giving it away for those who haven't taken it yet. I'm still being fair to you. Okay. And it won't happen in the final either. Okay, because it's not realistic. Okay, so now the key here is we don't have stats, we have data. So you'd enter on data, and then it'll ask what's L1, list 1 is L1, list 2 is L2. If it doesn't say so, you need to type second 1 and second 2. Just the frequencies are 1, that's correct. And we want to find out if mu1 is greater than mu2. So I hit enter on the greater than mu2. Any questions on that? For our class, pooled will always be no. Okay, there's some technical details where sometimes you can pool, but in my own work, I've never been able to pool anything in my own consulting work. So I don't teach it because I don't think it's very important. So hopefully you guys are okay with that. So just remember, pooled is no. Color, I don't care. Can I hit calculate? So I hit calculate, enter. Okay, and the important number is the p-value. 0.03 about. Okay, this is just kind of a basic question. No one's going to die whether you give candy or not. Do you agree? So probably 0.05 is the right way to go here. So now let me go ahead. And let's go to new share. And it's time for the conclusion. So what's the conclusion?
Reject the null hypothesis.
Yeah. So that means there is statistically significant evidence. Notice I'm not using strong this time because we had 0.03, which isn't strong. It's good enough, but it's not like super strong. To conclude that the population mean, and those words population mean must be there. Amount of money spent. For those given candy is greater than the population mean for those not given candy. Any questions on that? Is it starting to feel just like last week?
Yeah.
But now we have two means instead of one mean. Okay. Interpret the p-value. The p-value is about 0.03, about 3%. So I'm just going to say that instead of type it because it's the same idea as last week. And that is that if, and we need one more thing that came out of the calculator, which I'll just remind you of or tell you. And that was our x1 bar was about 56 and our x2 bar was 29. Is that clear? That was just in the calculator. And 56 minus 29 is what, 27? Any questions on that? Okay, so that's important to do that subtraction because we're going to be talking about the p-value. So that means we can say that if the population mean amount of money spent by those given candy is the same as the population mean amount of money spent for those not given candy, and if we did another study of 2, 4, 6, 8, 10, 12 people, given candy and not given candy, then there would be a 3% chance that the sample mean for those given candy is at least $57 more than the population mean. Any questions on that?
So for the proportion test, like earlier, how we interpreted the p-value was already in, that wasn't from the calculator, right? Because we said the difference was 6%.
Right, well, we got that because it was in the article.
Oh, okay.
Because they gave us the percentages instead of the value X.
Oh, okay, okay.
Here, I didn't give you anything. I just gave you data. So it's not obvious what the mean is until you look at the calculator.
Okay.
Does that make sense?
Yeah, so is that going to be the same for, I mean...
It's whatever's given.
Okay.
Sometimes they'll give you X, sometimes they'll give you P for the proportion. They give you X, and you want to kind of interpret the p-value, then you got to find P, which is just X over N. Does that make sense? Okay. I promise you that's not that bad. Okay. By the way, are there any assumptions we need to make for this particular example? What assumption?
That it's, the distribution is normal.
You're good except your grammar. The distributions are normal.
Okay.
But now we have two different populations, and they both have to be normal. Do you see that?
Yeah.
So I wasn't like dissing on your grammar. I was emphasizing that the difference between last week and this week is now we got two populations.
Okay.
They both have to be normally distributed.
So both sets of data, like Candy and none, have to be over 30 for
exactly. You gotta have both over 30, or you have to make that assumption, which is awful, by the way, because there's no reason to believe that it's normal. So this probably is a really bad study. You know, the answer is you should do more. But I didn't want to do that much typing in the calculator. Any more questions on this one before I move to the next one? As I mentioned, there's 3 types. I want to give you one of each today. And I know it's just you right now because Kyle had to go to work, I guess. And but everyone else was watching this as an archive video. So you saved the day for everyone else. All right, so let's go to select. There we go. And let's do a third one. Third one's going to look the same, but it's very different. I think I'm going to just do this part. Okay. So the question is, are people better listeners if they do not have use of their eyes? So if they're not distracted by looking at things, maybe they can listen better. Does that make sense? It's a nice little psychological study, right? So 12 volunteers were first given 100 words to remember while they were looking at the person speaking, okay, or at least able to look at the person speaking. And then they were given 100 words while blindfolded. Each time the participants were asked to write down as many of the words as they could remember. The table below shows the outcomes of the study. And then basically perform the hypothesis test. What's the difference between this example and the last one? There's a profound difference in terms of the way the study was done.
Is it the same sample, like the same people?
Yeah, it's the same people. So if you look at this 14 and the 17 here, that's one person had 14 right with seeing and 17 right blindfolded. So these are dependent. Does that make sense?
Yeah.
Because the idea is if you can remember more looking, you're probably going to remember more blindfolded, right? These are very much dependent samples. We often call these paired because each of this 14 and 7 is one pair. The 23 and 25 is another pair. Does that make sense? Mm-hmm. So we call this a test for dependent samples. Okay, and by the way, there's some deep math behind it, but you can trust me that if you have a choice, any guess on what's better, paired, dependent, or independent?
I don't know. I would say maybe independent.
It was a good guess, but actually dependent's better. Okay. The math is too deep for this class, but you can trust me. Do you trust me? Okay. So if you're designing a study, you're better to design dependent if you can. Okay. And again, I'm not getting into why. So this is definitely paired, which means that we're going to treat it a little differently in the calculator. So also, we're going to treat it differently on our hypothesis test. We can look at this as a single sample instead of 2 samples. So the way we look at this as a single sample is what we're interested in is how many more words the blindfolded was than the looking for each person. Does that make sense? So instead of this thinking of it as a 14 and a 17, we can look at it as a 17 minus 14, and we get the single number 3. Do you see that? So by looking at it as differences, we can think of this as a single sample. Any questions on that? And it's a sample of differences. So let me go and let's write down the hypotheses. Whoops, that's not what I meant to do. See if I can get rid of that. One more try. So we're going to have H naught, and this is going to look different than before. So before we would have said mu L equals mu B, right? Here we're going to say mu sub D equals 0. What do you think D stands for?
Dependent?
Good try. Difference.
Okay.
Right? It's the mean difference between the blind and the looking. Does that make sense? And 0, because if they're the same and you take the difference, what do you get?
0.
0, right? You take a number and subtract the same number, you get 0, right?
Oh yeah, okay.
Math makes sense, but again, this is new, so I didn't expect to know for sure. So we're going to have H1, and that is mu sub D. And now we have to think about it. And the idea is you always do the second minus the first for the difference. That's how the calculator is going to handle it, okay? So I like to grab an example that works for what we're looking for. If they're better listeners without their eyes, then notice the 14 and the 17. Is that an example of being better without the eyes?
Yeah.
If you take 17 minus 14, do you get a positive number or a negative number?
If you subtract 17 from 14?
17 minus 14.
Oh, positive.
Positive. So that means we're going to be greater than 0.
Okay.
So I recommend doing an example that makes a statement true for one of the pairs. And it's always the second minus the first.
Okay.
Okay, second column minus first column. So you wouldn't want to pick this 4 and the 3 because that doesn't work because that's looking is better than blind, right? Better memory than blind. And we're trying to show blind is better than looking. So that's 17 minus 14. Does that make sense?
Yeah, so you're trying to make the alternative hypothesis true.
Right, and find an example that makes it true, do the subtraction, and see if you get positive or negative. Okay. The only other situation is had it said, is there a difference between being blindfolded and having sight? So what do you think the inequality would be if that was a question?
Just not equal to.
Yeah, you'd have a not equal to instead of a greater than. There's always 3 choices, right? There's less than, greater than, and not equal to. Okay, so now, as you're used to, we go to our calculator. All right, so what we're going to do, let me clear what we had. I'm going to go to Stat. I'm going to go to Edit. Let's clear out our L1 and L2. And then I'm going to start typing in our numbers for looking and then type in the numbers for blind. And unlike the independent samples, it's very important that you do it in order. Okay, changing the order changes your answers. So 14, and then 23, and 15, and 37, and 4, and 19, missed again, 19, 22, 51, 37, 18, 16, and 22. And then for L2, we have 17, we have 25, 20, 37, 3, 29, 24, 53, 35, 20, 19, and 22. Okay, notice I have the same number of answers for L1 and L2. Is that necessary for dependent samples?
Yes.
Yeah, it is. Otherwise, it wouldn't make any sense because every person has to have 2 answers. Does that make sense?
Mm-hmm.
Okay, so now follow along because it's a little bit technical. First thing I can do is I'm going to go quit. So second quit. Then I'm going to type second 2. That gives you L2 minus second 1, L1. So, because again, we're interested in the differences. That's our new variable, right? So we need to give that variable a name. And the way you do that is you hit this STO arrow button. And then second 3, and we're going to store it into L3. Any questions on that? Then I hit enter. And the idea is the calculator now does all the subtraction without you having to do it by hand. Does that make sense?
Yeah, so if you went to edit, would it be in L3?
Yeah, let's do it.
Okay.
Very easy to check it out. And if I go to edit, and there they are.
Okay.
So it's a nice thing the calculator does for us. Then I'm going to go to stat. I'm going to test. Which test do you think we want to use?
I have no idea.
Okay, it's very simple. It's just the t-test.
Oh.
Now I just have one sample. Do you see that?
Oh, okay.
So we've massaged the data, so now we just have one sample, and we could just do a hypothesis test for the one sample.
Okay.
Does that make total sense?
Mm-hmm.
And then we know how to do this because we just have a sample, one sample t-test. Okay, and we hit enter. And we have data. So enter on data if it doesn't already say data. Mu naught is 0 because that was the right side of the hypothesis test. Most of the time when you do paired differences, you're going to have a 0 because you want to find out if one's bigger than the other or not equal to. The only time that I've seen is, let's suppose you want to find out if your method is doing better than, for teaching, for example. Let's say you're a 3rd grade teacher. And what you're going to do is you're going to test a before and after. The first day of class versus the last day of class. So then you want to be at least 1 grade level higher than when you started. Does that make sense? You know, in fact, more than 1 grade level higher. So in that case, you might have an L1 minus L2 being greater than 1 instead of greater than 0. Does that make sense?
Yes, but the null is still equal to
1. But that's a very rare occurrence. Pretty much every example you'll ever see is going to be 0. Does that make sense?
Mm-hmm.
But that one example, you know, there's a few others like that where you want to show you've improved by at least this amount, okay, or more than this amount, and that word improvement is important. You know, instead of just I've improved. Do you see how that works?
Yeah.
Okay. And then your list is not L1. What is it?
L3.
L3. So I go second 3. Freak is always 1. And we did have greater than 0. So greater than was fine. Blue is fine. I don't really care. And then calculate. Okay. So I guess today is a day of reject the null hypothesis. We got a low p-value. Okay. But hopefully by now you know how to do fail to reject too. Mm-hmm. Okay, so then we can go ahead. We got a p-value of about 0.02. And so we found the test statistic and the p-value. The test statistic, I didn't mention it, but it was there. T was 2.4. And the p-value is 0.02. So now I can do part B, which is state the conclusion. So let's do that. So hopefully you know there is what?
Statistically significant
Evidence to conclude that the population mean number of words a person can remember blindfolded is greater than the population mean, number of words a person can remember when they're looking. Any questions on this? Okay, so notice that this is all about the difference between the means. This mean is greater than this mean. It's not a single mean. You can't talk about any one mean, it's two means. Notice the word population mean. And I do take out points if you don't use the word population when you're talking about population, and you don't use sample when you're talking about sample. Is that clear?
Yeah.
Okay, so those are the three kinds of hypothesis tests for this chapter. We had proportions, we had independent means, and we have paired differences. Any questions so far? All right, I think I want, while I'm still on the screen, because it's the time I have, is give you the secret word. We're not done yet, but we're done with chapter 10 stuff. Oops, let's try this again. And the secret word is difference. Because this chapter is all about finding hypothesis tests for a difference. Okay, so now I want to talk about the project. Okay, I've already talked a bunch about it, but now you're ready for all of the details. Because the project is basically chapter 10. But hopefully you figured it out, that chapter 10 needs the rest of the chapters, right?
Yeah.
You'd have been totally lost if I just did this and you didn't know anything from before, right? That's my guess. Okay, so that's why it's chapter 10, but it's really all the chapters. Okay, and we're going to do, I didn't show you this in the webinar, but you can do a confidence interval for differences also. And when you do it in the computer, then it will do both at once. You don't have to say anything. It's just going to show it to you.
Okay.
All right, so let me go and let me find it. This one, I think. There we go. Okay, so the first thing is this is just the homepage now of the class. And I guess the easiest way actually is to go to the syllabus. And then we're going to go to Project 2. And this is Project 2 requirements. So I'm going to kind of read through this, give you ideas of what's going on. So first thing, the purpose of Project 2 is to use confidence intervals and hypothesis testing to support, to support or show lack of support for a research project. Does that make sense? You must first decide what you're interested in researching, then design your study and collect your data. Okay, don't collect your data and then start deciding. That's actually unethical, it turns out. You can't do a hypothesis test by looking at the data. That actually is important, but it's not what we're doing. Okay, and in fact, that's how artificial intelligence works. Is it looks at the data, it figures out what's going on, and then it understands the world. Kind of weird, isn't it? So it's a very important field, but it's not the field that I'm teaching you. Okay, so first you got to decide what you want to do. So the first thing, in terms of the order at which you do things, the first thing you must do, any guess? Same as Project 1?
Get a partner.
Good, get a partner. Okay, and I know you probably had no problem with it. But a couple of people had problems getting a partner and they didn't get one. And it's a very severe penalty if you don't get a partner. Okay, so you can use the same partner that you had in the last project, or you can find a new partner. But if you don't have a partner, you have a partner, do you have the same partner that you can work with? Okay, so you're good, but I recommend contacting your partner. Make sure we did lose a few students. Make sure the partner's still in the class. Or partners, 3 is better than 2, but 2 is okay. We don't usually get a lot of drops at this point. Those who stick with it, stay with it. Okay, so get a partner. The second thing you want to do is decide on your hypothesis. And it's not project 1, so don't get confused between project 1 and project 2. Project 2, you do not have to conduct a survey. You can grab data that's out there, say from the internet or from wherever it is that you can find. Okay, who's your partner again?
Amberly.
Amberly, okay, because I know Mariola did the snapshot day with me.
Oh, yeah.
And we collected data, but then there's been data collected for a lot of years, and she's going to be using that data. And that was not a survey or anything. That's just literally physically collecting data, and somebody else collected the data. You don't have to do it. Does that make sense? Mm-hmm. But the rule is that if you can get the data for the whole population, it's not an acceptable project.
Okay.
Because if you can get the whole population, there's no reason to do a confidence interval.
Okay.
Because you're 100% sure instead of having to be 95% sure. Does that make sense?
Yeah.
Okay, so you have to be able, it has to be a population that you don't know the whole population and can't really get the whole population without an extreme amount of work, but data that you can get. And you're allowed to do a survey, but you don't have to. You can go collect. Does that make sense?
Yeah.
Okay, you can't use somebody else's hypothesis test, though. If someone's already done and you're getting an article where they did the hypothesis test and got a p-value, that's not okay. So it has to be you grabbing data. Does that make sense? Okay, so that's the first thing. It must be quantitative. And the main reason for that is, do you remember what kind of sample sizes you need for proportions?
Yeah, like 100, 300, 200?
1,000.
Oh.
And I don't want to do that to you guys. It's just too much. So with quantitative data, you don't need so much data. And you must have more than 30 unless it's a situation at which some scientist or researcher has collected data already that you can grab, hasn't done a hypothesis test, and it's less than 30, but not less than 10.
Okay.
Okay, better is greater than 30, but if all that's out there is, say, 35, and it's not the whole population, it's a sample, it's all you can, it's, say, 25, then you can use that, but you just have to write about the fact that you're making some assumptions on normality. Okay, you have 2 choices for this project. It can be 2 independent samples, or any guess on what's the other choice?
1 dependent.
2 dependent.
Oh, 2 dependent. Oh, wait.
Yeah, you can never have 1 dependent. It doesn't make any sense.
Oh, okay.
Right? So kind of like the 2 examples I just did. So if you do a survey, the easiest thing to do is to ask each person 2 questions. But the questions have to be what I call subtractable. So you can't ask them how tall they are and how much they weigh, because it doesn't make any sense to say people weigh on average more than they are tall. Right?
Okay.
So if they're not comparable numbers, then it doesn't make any sense. So don't do it. So it has to be comparable numbers. And that's whether it's paired or not paired, dependent or not dependent. You have to have comparable, or there's no hypothesis you can do, and there's no confidence interval you can do. Does that make sense? Mm-hmm. So you could do a scale of 1 to 10 for 2 questions, for example. You could do some kind of before and after study of the same thing. Okay, something like, how much did you weigh 2 years ago versus how much do you weigh now? Or I don't know, something like that. Those are very comparable. Is that clear? Okay, so that's fine. And again, then you come up with your hypothesis. you should write it down formally in symbols. H naught, mu, either mu d equals 0, or you're going to have mu1 equals mu2. Okay? You might use subscripts that are more meaningful than 1 and 2, but you get the idea? Okay, then what you should do is, and of course you're coordinating with your partner, is you should post on the Project 2 discussion forum what your idea is and what your hypothesis is. And I'll let you know whether that can work. Okay? The reasons why they can't work sometimes, one is if they're not comparable, it can't work. If you try and do height versus weight, it doesn't make any sense, right? Sometimes you just can't get the data. And it doesn't make any sense because you won't be able to get the data and that doesn't work. Does that make sense?
Mm-hmm. So
there's some things you just can't get. Okay, things like something that's going to happen next year. You're not going to be able to get data on that because you only got a few weeks to this project. Okay, so there's different things. Those are the things that I usually turn down. And it's not to mean, it's because it won't work. Does that make sense?
Yeah.
Okay, so that's the next step is you post on the project discussion forum. Then the next step is to decide what your level of significance should be. That should happen before you collect your data or even look at your data. It's actually unethical to decide on the level of significance afterwards. Because then you're like faking it.
Yeah.
Well, you know, I didn't really get it low enough for my p-value, so I'm going to change my level of significance so I can say I'm right. That's just really wrong. Does that make sense?
Mm-hmm.
So you should decide on the level of significance. The confidence level, that can be done later, and it has nothing to do with the level of significance, just to let you know that. Level of significance decided on the type 1 and type 2 errors, right?
Yeah.
You remember that?
Yeah.
Confidence level is decided on something different, which I'll get to next in a little bit. So you decide on the level of significance. Probably write down your type 1 and type 2 error to decide on the level of significance. And you could even write that part of your paper. So I recommend putting that towards the front of your paper. The type 1 and type 2 errors. Okay, repercussions. Before you do the study, you don't know whether you're going to have one or the other. You have no clue. Or you might not have an error. Does that make sense?
Mm-hmm.
Then the next step after doing that, you collect your data or find your data. So you either do a survey or go, look up your data. Does that make sense?
Yeah.
Okay, so after finding your data, then you go to the spreadsheet. And let me remind you. Here's the spreadsheet. And what you're going to do is you're going to go to this TOVARE stats tab. You see that?
Mm-hmm.
And then you're going to type your data in. I called it first and second. The first thing you're going to do is you're going to highlight the numbers that are already there and hit the backspace just to erase them. Okay? You could use the same spreadsheet. If you already made a copy, you can still use that one. Otherwise, you'll have to make a copy again. Then you type in your first and your second. You type your data, I don't know, 23, 25, 27, 13, 15. You're going to have a lot more. 14, I guess. 18, 33, 11, 9, 7. Okay? So whatever you have, right? And now the key is use your eyes and decide, do you have independent samples or do you have dependent samples? It's all there for you. But you have to, don't look at the wrong one. Does that make sense?
Mm-hmm.
And that depends on your study, right? The computer's not going to be smart enough to know what you've got. Is that clear?
Yeah.
Because it doesn't know the context of which this data comes from. It gives you everything you need. So notice you're going to type in 0 for difference. Same thing, you'll probably have a 0 there. I'll just type in 0. Wait, sorry. Let's cancel. Yeah, for every 0 warning, cancel. Sorry, for this one, for independent difference is 0. Dependent difference, I think I forced you to be 0. You could change that number, but I recommend not changing it. Hypothesized difference is what that one is. And then it will give you, again, two-tailed, right-tailed, left-tailed. That depends on what your hypothesis was. Does that make sense? Same thing here. So you have to pick the one that's yours.
Okay.
It'll be one of those 6. Okay? And the numbers will all be different. Any questions so far? It also gives you the test statistic, t-value. Okay, then what you do is you say, well, if I have a 95% level of confidence, let's suppose you're doing independent samples, then here's my lower bound and here's my upper bound. Does that give good information, or is it too wide? Can it be narrowed out? Can it be widened out? Does that make sense?
Mm-hmm.
If it's not given any good information, then you probably want to go to 90% and explore. And you can write that part up. Does that make sense?
Yeah.
If it's giving you really good information, like more narrow than you would ever even imagine needing, you might as well go to 99%. Do you see that?
Yeah.
And then you get a different number. And talk about that in your paper, how you've looked at it and you've looked at the differences and decided whether it should be 95, 99, or 90. Does that make sense?
Mm-hmm.
Choose one of those 3. Please don't say that I used 95% because I had a 5% level of significance. That's wrong. Does that make sense?
Mm-hmm.
They're different things. Confidence intervals, hypothesis tests, they're different. Any questions on that? Okay, so let me get back to the Project 2 requirements. So you need to tell me about the sampling technique. You don't have to go on in serious detail, but at least mention a little bit. Convenience sampling is fine in this one. Okay? Just say you use convenience sampling, therefore there's biases, and that if you're going to do a study again, you do it in a better way. Does that make sense?
Mm-hmm.
So you won't lose points for convenience sampling, you'll lose points for not talking about it. Does that make sense?
Yeah. Okay.
So don't spend a lot of time on the sampling, is what I'm telling you. All right? So all this stuff I already said. So you need to give me a list of summary statistics. Not everything, but the main ones you need are this mean difference right here. That's the difference between the 2 means. And the standard error. So do you remember what the standard error is? What it means?
Not really.
Okay, and that's true of most people. Okay, those are the 2 main ones, is this difference in the standard error. If there's any that stand out, you can use other statistics also, because there's stats for A, stats for B, that's the first and the second. By the way, don't use this third one. Frequency thing, that's not going to happen in the project. Ignore those. All right, so what I did is I made a video on the standard error in Project 2. I'm not going to play the whole thing, but it's 15 minutes long almost, because it's a pretty deep concept. So I strongly recommend you watch that video, because I think, and you meaning y'all, like everyone who's watching this right now in class, okay, because it's the hardest part of the whole project right there. And that's why it's a pretty long video, just for that one piece. Okay, you need to give me a confidence interval for the difference. Okay, and again, that's all in that spreadsheet. And, oh, by the way, what I want you to do is which one you're using, if it's independent, I want you to copy, and you can Control-C it, and paste it in your project. If you're using dependent, then I want you to copy that and paste it in the project. Is that clear? Mm-hmm. So that's proving that you use the spreadsheet program. You do need to use the spreadsheet program. It's really easy to use, but you just have to use it. Did it look pretty easy, by the way?
Yeah.
You just type in the data and you look. Okay, so I promise you it's easy to use. Okay, so that needs to happen. So you need to do at least a full paragraph on the confidence interval for the difference. So just like in Project 1, everything you do should be about why you care. So when you get that confidence interval, what does it tell you? It's helpful to have a client. It's not a complete requirement, but it's a strong recommendation, like in the last project, because then you can have a tense of this is what the client needs to do after seeing this confidence interval. Does that make sense?
Yeah.
Okay. So that's what it's all about, is talk about what you're going to do after seeing that. After seeing the standard error, what decisions might be made. After seeing the confidence interval, what decisions will be made. Is that clear?
Mm-hmm.
Okay. This is not a homework assignment. This is a project. So if all you do is write down that if many studies were done with the same sample size, then each one would have a different confidence interval, and 95% of them would contain the population mean difference, that's not acceptable. Because all you're doing is copying the words of the homework assignment. You need to fully get into it. Does that make sense? Write a whole paragraph about what all that means. Does that make sense?
Yeah.
Okay, so this is a lot deeper than the other stuff you've done. Okay, it's one of the big mistakes people make, is they just copy down what they have in their notes and they don't analyze it. Okay. So same idea with hypothesis test, is you conduct the hypothesis test and then write down what the results are. Okay. Write down why you care, what decisions are going to be made from the results. Write down the p-value and interpretations. Notice that the standard error directly relates to the p-value. It also directly relates to the margin of error. All that's in that video that you can watch. And it's in some of the old videos, but I focused on it with that one video. And I did an example. Okay. So after looking at the p-value, is there reason to conduct another study? Okay. So remember that you only conduct another study if you weren't able to reject the null hypothesis, but you were close. Does that make sense? And if you conduct another study, you got to have a bigger sample size. Okay. And what might that sample size be so that you can get your p-value smaller? Okay. Or bigger, by the way. If you get a p-value of 0.95, that means the truth is revealed and you were just wrong, which is better than the truth not being revealed at all. Does that make sense?
Mm-hmm.
Okay. Let me know what assumptions you made. So again, if you have a small sample size, then what will definitely be one of the assumptions?
It's normally distributed.
Right. And remember the grammar? They are normally distributed.
They're normally distributed.
Okay. And so that's important. And another assumption that you're most likely to be made is that the sample was representative. So if you use convenience sampling, that's a pretty big assumption. Does that make sense?
Mm-hmm.
Okay. So I have, and I'm going to let you read through all the words because it's all online, but I want to explain all the things you're going to have to do. Talk about why your results are important, not just in the conclusion, but throughout the whole paper. Okay. And at the end, maybe talk about what further studies you can do. Any questions on that?
The only thing, when we post on the Project 2 discussion forum, what exactly do you want us to include so that you can tell us, like, this is good or no?
I would recommend your null hypothesis and alternative hypothesis in symbols and words. Does that make sense?
Yeah.
Those are the biggies. If you can give me the null hypothesis and alternative hypothesis in symbols and words, one is I can let you know if they work. And the other thing you might want to mention, if you can do a survey, your questions or question that you're going to ask. So it's going to be 2 questions if you're doing paired, and you could do, say, 2 populations and 1 question if you're doing different populations. So if you're doing men versus women.
Okay.
Okay. Does that make sense?
Yeah.
And that's probably enough. And just like the last project, you if you email me your draft, I'll read it and give you lots of feedback.
The Wednesday before it's due?
Yeah, so notice that this one is due. Let me go grab it. On June 17th.
Okay.
So I'm just looking at my calendar. The Wednesday before June 17th is June 13th.
Okay.
Okay. And don't wait until, Wednesday evening to start writing the draft.
Yeah.
That's a bad idea.
And I don't know if this is right, but on my calendar I have to post the project idea on the forum by tomorrow. Is that still?
That was recommended. You don't have to.
Okay.
In fact, most people, for you that you might be able to do that, most people can wait a few more days.
Okay.
Because the reason why you might want to wait a few more days for most people is they're taking the test tomorrow.
Yeah.
And that's first on their mind. But maybe by Friday might be a better date. So if you can, just the idea, it doesn't take long to come up with an idea.
Yeah. Okay.
And so a couple days should be plenty of time to come up with an idea. What's going to take long is writing it up.
So I guess I'm just having a hard time wrapping my head around it since I don't have the data. I'm not looking at the data or any study, but you can determine the null and alternative hypothesis before even knowing how you're going to design your study or anything like that?
Yeah, you want to say, okay, what do I think is true? And then you design a study to show that it's true.
Okay.
So let me give you an example. It was a really cool example. I had a few students that they wanted to see if men are more willing to, if there was a difference in gender in how many hours people are willing to volunteer. Does that make sense?
Mm-hmm.
So that was their idea. So then the null hypothesis was mu for men was equal to mu for women. The alternative with mu for men was not equal to mu for women. Does that make sense? So then they had to decide on the study, how they designed it. And what they did, it was kind of cool actually, is they set up a table in our commons at the college with a volunteer for, I don't remember, there was some main event coming up in a week. And they had people walk up to the table and they had to fill out a volunteer form on how many hours they're going to volunteer for this. And then at the end, they told people it was just a joke. But it was a really cool study. And some people were kind of disappointed. They really wanted to volunteer. But that's the kind of thing. So they didn't really know ahead of time what they were going to do, but they knew what they wanted to do is study. Does that make sense?
Yeah. Okay. Yeah.
And sometimes it's obvious how you're going to do it, right? Like if you want to see if, the temperature is higher in Modesto than it is in Sacramento, well, then it's kind of obvious what you can do. You're going to look at temperatures on different days in Modesto and Sacramento. Does that make sense?
Mm-hmm.
So sometimes it's really obvious, and sometimes you got to get creative.
Okay.
Any other questions?
Not right now, no.
Okay. I know most people are studying for the test, so I think that's why it's just you. And Kyle's dealing with the test right now. He's actually working tonight, so he doesn't have to work tomorrow.
That sounds stressful.
What's that?
That sounds stressful.
Yeah. But that's why I'll tell you, it's just a good lesson in life. Planning ahead is a good thing.
Mm-hmm.
And this is something and the final exam, since I'm here, notice it's June 27th.
Okay.
I don't want anyone in the whole class to be surprised when I tell them a few days before, hey, how come you haven't told me when you're taking it? You could take it June 26th or June 25th, that's fine. But the deadline is strict, it's not changing.
So then is the last lecture going to be that week before, like the 19th or 18th or 19th?
Yeah, the last lecture, let me look at my calendar. Yeah, will be the 18th or 19th.
Okay, so it's not like how the midterm was, how there would be like a lecture the week of the final.
Right, because there's nothing to talk about after the final.
Yeah.
Whereas our class is still continuing next week and this week. There's still a chapter to do and a project. But once the final happens, then you get to party or whatever you do. Okay, the class is over. Okay, there isn't anything else to talk about. Okay, and just notice I'm not a procrastinator, so I will have the midterms graded by the end of the week.
Okay, sounds good.
Yeah, and depending on technology, last time I had trouble and it didn't work, I'll try and do a voice recording for everyone of feedback, individual.
Oh.
Yeah.
Oh, okay.
Because you don't get your test back.
Yeah.
It's online, so I can't just hand it to you.
Yeah.
So what I try and do is do a voice recording. If I can't do the voice recording, I'll type a lot.
Okay.
Okay. Any other questions?
No. If I do, I'll post them in the thing.
Okay.
Cool.
All right. Well, thanks for coming. You saved the day.
Yeah. What would you have done if no one showed up?
I think we cancel it.
Oh.
Which is bad for everybody.
And then just nothing gets recorded?
Yeah, then you don't get to hear about the project.
Oh.
So you really saved the day for everyone.
Cool.
That's all I can do. I'm not going to do it by myself. That's not what these are about. That's what the long videos are about.
Yeah. Okay.
Okay.
Cool. Well, have a good night.
You too. Have a great night. And for all of you who are watching this as an archive webinar, have a great night too. And good luck on your midterm.